Hey, what's up, guys? It's Blank here. Today we're gonna talk about this tweet that I saw on my For You page. It's from Matthew Colina. He is a core contributor at Node.js, and he has a very uh, interesting benchmark that he's trying to show us here. So you can see that this guy is really, really smart. You can see that he's TSC chair, lead maintainer at Fastify, board at OpenJSF, conference, Neoform, Platformic. So he's a really, really uh, in-depth guy into understanding on how exactly do Node.js runtime, Bun runtime, all these runtimes work. I think it also contributed in Chromium at some point. If you remember the bug that he had, bugged. If you remember the blog that we had about we cut Node.js runtimes memory usage in half, that was also done by Matthew. Is a really smart guy basically. So if we so here we can see that if we benchmark Tanstack start React router Next.js running the exact same e-commerce app at 1000 requests per seconds on a containerized platform basically. The results were eye-opening. So you can see that Tanstack start comes up with 1041 requests per second, success rate of 100% 12.79, and all the way to the bottom it's like Next.js with 11 seconds of latency. This is crazy. 187 requests per second with a 55% success rate. So 45% of the requests are failing in Next.js because of the latency basically. So this is very, very interesting, and I don't think that I think that this is a problem that Next.js needs to fix as soon as they can, and we'll see why this happened. We are gonna understand how exactly did Next.js fuck up basically, because this does not look good for Next.js, right? You can see Tanstack start with 100% average latency of 13,041, React router with 833. So I think Tanstack start is faster because of the optimizations. It's the same as React router, I feel like. But yeah, Tanstack start is faster. This is not a one-to-one comparisons apple to apples, but because Next.js has a lot of legacy things and Tanstack is new as hell. So yeah, this is true that this is actually the case right now. So if we understand how what the benchmarks were, this would be giving me a better picture as well. The setup a trading card marketplace thinks TCG player with 10,000 cards, 100 sellers, and 50,000 listings, full server side rendering, no caching, random 1 to 5 milliseconds simulated database latency, which happens. Okay, same data, same UI, same tailwind stylings, 3 framework, 2 runtimes each. We built 3 versions with help from Cloud Code. Again, I don't know, Cloud Code is the should be the ones to be used here, but okay, for benchmarking I would not prefer using it. uh, Tanstack starts with 997 requests per second throughput, 12.79 milliseconds average latency on what, 100% success rate. At 1000 requests per second, average response time stayed under 13 milliseconds. This is a performance leader. So, what is another runtime for Node.js based applications? Basically, Chromium based backend applications. So yeah, again that happened. React router solid and reliable. Okay. So again, Tanstack start was the first with React router solid and reliable. 793 requests per second on what and 100% success rate. Zero failures. Again, this also happened. Okay. Next.js 15.5.5 could not handle load. 8 to 11 seconds average response time. 40% of requests failed. It's 45%, but this is still insane that actually happened. This is not the end of the story. Next.js 16.2.0 Canary 0.66 throughput more than doubled with 322 to 701 requests per second. Real progress, the gap is closing. Yes, it is, but I would like to understand why exactly this happened. The best part of this project was the collaboration we shared with Flame Graphs, which is a graph where we show actually what the performance heuristics of a running process is, and how exactly what functions are being called at some point, etc., etc., and how long does the function take. So you can see flame graphs a lot of places. It's a very interesting graph. So yeah, they shared it with Tanstack and Next.Js team using platformic flame. Both teams found and fixed critical bottlenecks. Team Nutkins from the Next.Js is the core contributor there, found a hotspot in React server components and JSON parse, which we're gonna check out with a receiver callback forces a C++ to JS boundary crossing for every key value pair, which is insane. His fix landed in React itself with 75% speed up in React server component deserialization. So this will be in the client side. Benefits for every React framework. The Tanstack team had a similar arc. Initial benchmark version 1.150 showed 75% success rate and 30 per seconds response time. Had a similar arc. They did the same thing and they had 252 times performance from seconds to milliseconds. His is insane, by the way. That Tanstack is so fast on this. So yeah, you can see that full benchmarks data. We are gonna see this blog as well. Golemo has something to say here. The top G. We will be close to parity here soon, where frameworks will basically not make a difference. Web streams being slow hold us back, which may be kicked in of this research. Team is on it. Thank you so much. The thank you so much is basically what every time he says. But fine, we are gonna look into it a bit more. So I'm gonna tell you what exactly happened in this and uh, why exactly did Next.js lose so much. Okay, so imagine that this is your server, right, and this is your client side application. What React server component does is that it renders the React component on the server, it converts it into HTML. So on the first request you're gonna see that you're gonna have your HTML being rendered on the server with all the data mutations and everything done. It's gonna be shared to the client with some JavaScript, and that JavaScript tells it, hey, that these are the event listeners, these are the things that you have to hydrate this HTML. So client sees that, client says, okay, we are hydrating this HTML, uh, and then there is a two-way data communication between the client and the server based on the server components, server actions, everything like that. That needs to be done in a secure and formatted way so that nobody actually hacks something. So React Flight Protocol is a very hacky thing currently. If you remember, the React to shell bug also happened in React Flight Protocol. So React Flight Protocol is the protocol that actually handles the JSON to HTML and HTML to JSON conversions here. No, what it does is basically imagine that server returns back the HTML with inside a JSON object, and that JSON object is turned to client, and client sees that, client pushes the HTML object inside the DOM like the way React does it, and then client actually uh, puts all the event listeners everything and returns back to the server some data, and that's what happens. And this is such a universal thing that should happen in React server component, that React Flight Protocol needs to be hacky. It cannot be simply implemented because this client to server architecture would happen on every single time, on every single framework, on every single place basically, and there is no way you could account for that everywhere. So that's what happened. And what React Flight Protocol does is basically it's gonna json dot it's gonna json dot parse this object in client side, and suppose that the children also have another object, right? Children also has another object, so it's gonna have to parse that, and if it has another object, it also needs to parse that as well. And this needs to happen on every single render, every single re-render, every single time, because it needs to be consistent. And this is where the bottleneck lies, that hey, if we are recursively calling the json.parse, which actually what it does is that on json.parse it returns the JSON object, it goes to the CPP land, it converts it to object notations, rehandles the reference and returns it back to JavaScript. So this happens over two languages every single time, and it caused a lot of problems in performance heuristics of the React Flight protocol itself. And that's what the fix was as well. We're gonna see the fix. But yeah, uh, this happened, and we understood that hey, we need to do this in JavaScript land. So what the fix was is, once json.parse is handled, like is called once on the object, instead of doing it recursively again and again, we are gonna walk the JSON body, right? We are gonna see the strings of JSON that the children might have, and we are gonna convert it into JSON objects internally in JavaScript land itself. And that's what the recursively walk, actually this is gonna be recursive. So recursively walk the JSON body and convert it all back to uh, JSON objects basically in JavaScript land. So they re-implemented this in JavaScript, so we don't have to redo this entire thing in CPP land. So that's where the problem is. Problem is not to convert JSON. Problem is here. This might be way longer than you might expect. And yeah, so json.parse was used only once, and we're gonna see that fix as well. So yeah, if you see this fix, walk park JSON instead of using reviver for parsing React server component payload. And Team Newtkins did this with unstubable as revivers. So you can see that yeah, they did fix it. And you can see even in the fix, instead of calling the parse model every single time, they did remove it. Yes, they did. They're gonna check if the value is an object. If not, we are gonna revive the model. If yes, then they're gonna revive the model and do something with it basically. And you can see that it's uh, basically converting it back to into object. And you can see that it's gonna be in client JS and React no flight client JS as well. So that's is it basically. This is where the fix is. Every single time, instead of calling the JSON object once, we are gonna call it instead of calling it JSON object multiple json.parse multiple times, we are gonna uh, call it once and then figure it out from there. So this is a very React based approach, but you can see that hey, this was not something that could be accounted for without testing these things. So I really think you should not take, if you're anything to take away from this video, it's more that this framework authors are smart to understand that this is happening. They are not stupid to understand that hey, our framework might be buggy and stuff like that. And yeah, basically it's a collaborative thing. Don't take it into competition mostly. I'm not saying Tanstack Start is better than Next.js or something like that. It just happens when you have a legacy framework that performance might be a big issue. So we are gonna see what exactly did uh, Team Newtkins did as well. So Team Newtkins also verified the changes to hold a 30% speed up on table benchmarks. So you can see that he did this internally to Next.js as well. He fixed a lot of things. He updated it. He uh, made it so that the json.parse thing did not happen, but a trivial retriever uh, gives a better gain. So you can see that he implemented it both into Next.js as well as into React Flight protocol. So everybody is gonna benefit from it. The findings that he did. So yeah, but this is a very big issue now that Next.js needs to fix and needs to re-engineer. If you remember, last 2 to 3 weeks ago, the VNext team also came up with a Next.js API service and implemented VNext. You can see that it was fast, 4.4% faster builds, 57% smaller bundles, 94% API coverage, and 22,080 plus test coverages as well. 94% workforce. Next.js 16 works out of the box. The only things that might not be changing is a lot of like infrastructure things that they might not be able to do right currently but might do in the future. So yeah, traffic aware pre-rendering as well. So this is insane that this is actually happening. I think Next.js needs to take a step back as well to re-engineer everything, to re-engineer, rethink how they could actually uh, restructure Next.js to work properly. And yeah, this is very interesting things. I would say don't take anything that these people are stupid. They people doesn't and don't understand what they're actually doing, but understand that hey, sometimes the problems are just too complicated for you to understand them without testing them, and this was a test that made them understand. So I would say thank you to Matteo, thank you to Golimo, thank you to Tim Newtkins, every single person who actually collaborated on making this happen. This is like this might never happen if we were actually very competitive in nature. I hope so this continues in the future because this is the way we understand how exactly uh, the performance heuristics is working. So if you can see in Next.js blog post, we reconfigured the web streams to make them 10 times faster. The problems: node API, stream readable, stream writable, stream transform. This is very basic. Again, what we build library called fast web stream, which implements the what WG readable stream, writable stream, transform stream. So they remade their own web stream API. So React Next.js works on a web stream API. So yeah, they are also doing the same thing. React flight pattern where the gap is largest, readable stream, type byte. As a React renders each component, see each component. Control running key, UAT array payload, unit array payload. So you can see that this happens every single time, and we do not want it to happen every single time. So yeah, benchmarks, you can see transform chains, white stream, response body, construction, spec compliance, how we deploying this. uh, so where did this actually deploy? Mateo Colima submitted it to Node.js stream, the fast path web streams to pipe to. So actually they actually updated it to Node.js streams as well. So you can see that this is just like the collaboration on this led to a lot of changes into a lot of other things, a lot of other projects. So yeah, this actually happened, and it's gonna cause a big issue. Like it's gonna cause a big performance gain in a lot of applications out of the box. Just update your applications to latest versions as soon as you can. uh, so yeah, they are still trying to understand, and they're still trying to fix it. So let's just wait for a fix, and if something else happens during we are fixing it, I'm gonna talk about it. We are gonna talk about it. We are gonna understand what happened, and we are gonna keep an eye on it. So thank you to Maul, thank you to Matteo, thank you to every single person who collaborated on this. So if you like this video, please share, please comment on the video. Tell me how what exactly do you think happened, and how can we as framework users or framework uh, enjoyers, basically I'm gonna say, uh, use this or take away from this. So thank you so much.